Ayo, GG. Yeah. 시작해볼까? 뭐. 얘 좀 봐라, 얘 무슨 일이 있었길래 머리 잘랐대. 또 얘 좀 보라.
Dune.
Alright.
Electrolytic galvonic cells.
Things you need to know before you start this chapter. You need to know oxidation number and half reactions.
And those things you need, like your periodic table, your equation sheet, and your half reaction reduction sheet. What?
Here we have the parts of a voltaic cell, which is also called galvonic. A good mnemonic to remember it is that they both have a V in them. And this is versus an electrolytic cell, which is on this side. Okay, let's begin. Okay, this is a galvanic cell. This can be presented in multiple ways, but for our purpose, we'll just present it in this way. Okay, these two are metal strips. They're called electrodes. For our purpose, we'll call this one the cation and this one the anion, but it has no specific order. The cation is the more positive one of the two. You can remember that because the T looks like a plus, while the anion, in contrast, is the negative one. You can remember that it sounds like anti. Okay, these two are the ions. This is the ion solution of the cathode, and this one's an ion solution of the anode. Okay, this is a salt bridge. The ions transfer through these, but we'll get in more in depth later. And this is the voltmeter, and the electrons are transferred up here. And they transfer from anion to cathode.
Hi. No, this is electrolytic cells. The only difference between this and galvanic is that it goes from cat to an on the electron side. So when you go left to right this time. And then the only difference is that galvanic does not need any supply given to it for electricity. But in this case, electrolytic, you are given a power supply for the reaction to take place instead of for a natural occurrence. So that's pretty much about it. Electrodes. They are non-reactive metals. Common are platinum and graphite. Okay, this is the salt bridge. And the salt bridge is a porous barrier that allows the ions to migrate from each chamber with electrical neutrality. And within the salt bridge, ions will migrate and will not contaminate with the solution, and they'll just keep separate. And if this process were not to happen, then the electrons and everything would just halt. The voltage would not be able to equal anything but zero because cations would build up.
Oh, this is hard! Okay, a note to remember is that the galvanic cell, the delta G is negative.
Electrolytic cells. It is powered by a power supply, therefore the delta G is positive always.
And since this one is happening by itself, it's happening spontaneously by itself. That's how come it's negative. Peace.
For cell EMF, you have to make sure that the salt bridge and the entire process is all at STB 25% or 25 degrees Celsius and 1 ATM at 0 Kelvin. Once the cell EMF progresses and reaches the 0, it will be dead. Okay, cell EMF. One thing you need to know is it goes from high energy to low energy. Another thing you need to know is another word for cell EMF is the energy of the cell, which is how you find cat minus an. And another thing you need to know is that it is also spontaneous. It is spontaneous. And that is when it is spontaneous when it goes from high energy to low energy. And cell EMF is like the energy of the cell is potential difference between the two different cells, the containers.
Whatever you want.
Delta G's. There is 3 different delta G's. There is G. I hate tartar sauce. G is just G. Then it's going to be delta H.
AOGG.
Minus T change of S, which is temperature and entropy. And then there's another delta G formula where it's G, I hate retweeting link, credits to Lawrence, which is negative RT ln K, which is the R constant, T the temperature, natural log, and then K Kelvin. And then the last one is negative N F E. And the negative N you get from the number of moles, whether it's given to you or if you calculate it earlier in the problem. And then F is Faraday's number, which is 96,500 coulombs. And the E of the cell is cat minus N, so whatever you find there. And that's it.
And remember, coulombs is amps times second. That's not on the back of your equation sheet, while the rest of them are. Ha 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 ha.
Well, what I did here is I did electron of the energy of the cell, and its formula is cat minus N. And in this case, let's say the cathode is 1.53 volts, and the anode is negative 0.53 volt. 3 volts. So what you're going to do is you're going to, since it's a negative and a negative.
Did you say negative?
Make it a positive, and you add it, and it's going to be 2.06 volts. You have to remember volts, or else you'll get it wrong in the AP test.
Okay, these are two equations that can be found on the back of the equation sheet. You do not need to memorize them. You just need to know what each part means. These are to find the energy of the cell. And the standard, and remember standard EMF is 1.10 volts. And also Q is the reaction quotient, which is products over reactants, and you can't include solids in them. And that K equals K at standard state, which we explained earlier.
So this right here is line notation. Right here is what is the actual line notation. The X's represent the actual solid forms of the element, and right here anode and cathode is depending on what the energy of the cell is. And so whether it's anode or cathode, it will be placed as an ion. So let's say I were to have a salt bridge and the electrode was Mg solid, then that will go under cathode or anode, whether or not it is the more positive or more negative. And then within that same beaker will be its anion, which is Mg2+, which would go on either the left or the right side, representing the X. And each line right here represents part of what's going on throughout the process. The first part is the phase changes, which is when the ions are transferred into each one. Those are the phase changes. So at the end. And the electrodes, which are the two metal strips, will also occur at the end. And in between both, if you can see it, it's a salt bridge or a porous disc, which is the salt bridge that connects both beakers between both metal strips and their ions or anions or cathodes.
Now that we taught you how to do electronic and galvanic cells,
It's time that you should know what to do with it.